This is a video on conductors and insulators. A summary of the video is on the screen there. First of all objects have a resistance to the flow of current. So whether they are liquid, solid or gas, whether they're metals, they all have a resistance. If they have a small resistance to the flow of an electric current, we refer to them as conductors. And if they have a large resistance, we refer to them as insulators. Now you'll also see in the book that it says conductors allow a current to flow and insulators do not allow a current to flow. And for junior cert, that's exactly what you should be saying. So insulators stop the flow of an electric current, conductors allow an electric current to flow. But in reality, all objects have a resistance, and if we're to compare objects with different resistances, small resistance means they're conductors and objects with large resistance are insulators. So let's start with this, and if I close the switch, we'll see that the bulb lights. Now, I can change the resistance here, and if I increase the resistance of this, we'll see that only a small current flows. Now, that means this thing is becoming more of an insulator. If I decrease the resistance, it means that the current is easily able to flow. As a result, then, with the resistance small, we can say that this behaves as more of a conductor. Okay. The other thing to keep an eye on is as the resistance increases, the bulb is dimmer, and that's because the current is flowing at a slower rate, and that current carries less energy when it's traveling slowly as opposed to when it's traveling quickly. So when it's traveling quickly, it brings a lot of energy with it, so the bulb will be bright. Now, the previous bulb had a resistance. Each of these bulbs also have a resistance. And what we do is we can add the total resistance of those. So if it was 10 ohms, 10 ohms and 10 ohms, the total resistance is 30 ohms. So we could replace the three of those bulbs with a single bulb there with a resistance of 30, and the current flowing in the circuit would be the same, and the amount of energy in total would be the same as well. So let's close this. And we can see there that the current flowing is the same as the previous case, and if we were to add up the energy of these three bulbs, it would equal the energy of that bulb there. So the total energy is still the same. Alright, so let's increase the resistance, and we'll consider these three to be exactly the same, or to be a singular component. And we can see there that the current barely flows, so the three of them together behave as an insulator because they've got a high resistance. Now, there is a mandatory experiment that you need to do for junior cert, and that is to investigate, it's not mandatory, and there is an investigation you may do, and that is to determine if something is a conductor or an insulator. So you'd set up a circuit like this. You'd have your battery, your wires, you'd have a space there, and you'd have a bulb. If the bulb doesn't light, the object in here is an insulator. If the bulb does light, the object in there is a conductor. So let's start by placing just a piece of wire in there. So the bulb lights, therefore that piece of wire is considered a conductor. Let's put the dollar bill in there. The bulb doesn't light, so the dollar bill is an insulator. The paper clip. The bulb lights, so the paper clip is a conductor. Let's try the coin. The bulb lights, so the coin is a conductor as well. And remember, if it's a conductor, it just means it's got low resistance. Let's have a look at a few more. The hand. The bulb doesn't light, so the hand is an insulator. In other words, it's got a high resistance. Obviously, we need to check the dog. The dog is an insulator, so he's got a high resistance as well. And then finally, your pencil. Now, we're talking about the graphite in your pencil there, so that's the metal in your pencil. And that metal is indeed a conductor. So the graphite, or the lead as you might call it in your pencil, is a conductor, so the bulb lights. Okay, so you need to know this setup, you need to be able to do the experiment. And before we go back and just recap what I've mentioned, the air connecting the two of those is an insulator as well, otherwise the bulb would light. And that's exactly how a switch operates too. So when I put in the switch, right now there's a gap here. There's air between the two of those contacts. And as a result, the bulb doesn't light, so air is an insulator. But when I close it, we have a conductor there, and the flow of charge, or the current, is able to be conducted through the wire. It's able to pass or flow through the wire, in which case the bulb lights. So in summary, all objects have a resistance to the flow of current. Objects with a small resistance are referred to as conductors. So conductors will allow a current to flow through them. Objects with a large resistance are called insulators, and insulators do not allow a current to flow through them.